Hi everyone, here's one more long and boring episode from GPS Patron. Today I'm going to test the time saver. I actually have two time savers produced by oscilloccords. The bottom device is model 5420 and we will use it as a reference. The unit under test is the 5410. This is a pretty outdated device, but it's still popular in telecom and finance. The connection diagram has not changed much since the last test, so I will not explain in detail. This is the cable from a GNSS antenna. The RF signal through these three dividers goes to the reference time saver, to the spoofer channel, then to the SDR and U-blocks. The fake signal mixes with the real one using this RF coupler and goes to the device under test. I am logging into the control panels of the time servers. On the left is unit under test 5410 and on the right is the reference time saver 5420. Okay, as a reference time clock we set the GNSS module. It's okay and active. Here you see the main status of the time servers. The clocks are locked to the reference source. Now let's see what the GNSS modules show. Okay, the device under test is configured to receive GPS and Galileo signals, a reference receiver in a GPS plus GLONASS mode. All satellites not badly visible. These are PPS signals. The top blue one is the reference, the bottom red one is from the device under test. Let's now see the whole pulses. Okay, nice. Let's put these windows here. Okay, and let's now run our GP simulator. Okay, we start with a simple non-coherent attack. I choose a simulation of the past time. Then I select the current timestamp and subtract 1 hour back. Then I update almanac and ephemeris data. Okay, nice. Now I update the status pages. Please look at the current time of day fields. The timestamps on the reference and the device under test are almost identical. It's time to launch the spoofer. Okay. Let's go. At the bottom you see the warning and error messages that the GNSS satellites are not visible. This is a normal scenario for a non-coherent spoofing attack. GPS satellites disappeared. Let's now check the clock status. Time saver has gone into holdover mode. Let's take a look at the reference time saver. It's locked. The GPS module is active and all satellites are clearly visible. Let's wait and see what happens. I have constantly refreshed the page to see the current information, not very comfortable. The Galileo satellites have also disappeared. This is normal because the fake GPS signal blocks the reception of Galileo signals. Let's wait and update the page. Nice, we are seeing our fake satellites, so these messages will disappear soon. Okay, great, let's go to the time clock menu. Here you can see that the GPS module is fine and the time saver is adjusting its internal clock. It's in tracking mode. All time servers are very inert and take considerable time to adjust the internal clock. I don't really think that it's going to happen quickly, so I will speed up the video here. The PPS phase of the device under test has finally shifted great, and look at the timestamp here, it's 1 hour less than the reference time. Let's update all pages. So, we spoofed the time. We see the difference between the reference and the device under test in about an hour. If you want to understand why there is an extra 15 seconds gap here, take a look at my previous video. Let's now see how long it takes to restore the device when I turn off the spoofer. Let's note the time and speed up the video. The timestamp was recovered 7 minutes after the spoofing was disabled. This is quite interesting because it took less than 5 minutes to spoof. Let's go for more advanced attack methods. Let's start the next test. I'm gonna shift the PPS phase by 100 microseconds. I'm setting the real-time simulation mode and synchronous spoofing, and start delay is 100 microseconds. Okay, now download Almanac and Ephemeris files. So I guess we're ready, and let's go. As you remember, in synchronous mode we have to wait for GPS frame beginning to start simulation, so we need to wait 30 seconds. Okay, it launched, and again we see the same behavior as in the previous test. Here we see some error messages. However, this time the embedded GNSS receiver quickly switched to our fake signals. Let's go to the time clock menu. Nice, GPS clock is active and accepted by the time saver. It's in the tracking mode, and I think we will see the PPS phase jump in a couple of minutes. Speeding up video. Great, it took 4 minutes to adjust the internal clock to our fake signal, and exactly for the predefined 100 microseconds. Go on to the next test. This time I will launch a coherent attack, and then I will try to shift the phase of the PPS by 1 microsecond. Here you can see that the phase difference between the reference and the device under test is less than 50 nanoseconds. Let's now set start delay to 0. Okay, great. And we don't need much power here. Let it be minus 110 dBm and launch. I expect that after activation of the spoofer, the time saver will instantly switch to our fake signals, and it will not show any errors or even warnings. Why? Because in the first phase of the coherent or synchronous attack we generate a signal identical to the real one in all parameters. The signal is enabled, and as expected we see a great picture here. The GNSS receiver instantly accepted the spoof signal. That's the coolest thing about the synchronized attack scenario. In order to confirm that the receiver is successfully spoofed, let's reduce the relative power for satellite number 8, for example. Let's update again. I think the signal-to-noise ratio values are not updated in real time. Let's wait and update the data. Yes, you see it works. Let's now check the time saver status. Great, it's locked to the built-in GNSS module, and now would be a good time to try to move the PPS phase. Let's apply minus 500 nanoseconds. Let's scale up. And now all attention to the PPS phase. Can you see that? The phase is moving. I will speed up the video here. So in this video I demonstrated 3 attack scenarios. In the first one, I moved the timestamp back by 1 hour. In the second, I shifted the phase of PPS by 100 microseconds. And in the last one, I showed a sophisticated synchronous attack scenarios. I smoothly and stealthily shifted the phase of PPS by 1 microsecond. The time saver did not show any warning or error messages. Please leave your ideas on comments on what I should test next. Maybe a drone from DJI or RTK base station. Bye!